Hi everyone, very good evening. Please let me know in the chat if I'm live. Really sorry for the delay. I got stuck in some traffic. Please let me know in the chat if I'm live. Today we are going to have an amazing session, like a mega session. It's a marathon session. We will be solving 50 MCQ problems commonly asked in any interview round, in coding interviews basically. So before coding interviews, generally we have screening rounds in almost all companies, and in screening rounds you are asked coding problems or like MCQ problems, and today we will solve those MCQ problems specifically on arrays and linked lists, and it will be an exhaustive list of 50 MCQ problems which will help you. So if you're watching it live, I want the session to be interactive. Write your answers in the chat and then we will discuss the problem. Okay, am I audible and visible correctly? Am I visible? Please let me know in the chat. Cool. So as you all might know, I'm like Jay, and I'm a machine learning engineer at Google, and these are some of my credentials. So before starting the session, like I would like to introduce myself as an educator. In this session, we're gonna crack any coding interview. We will be solving 50 MCQ questions commonly asked on arrays and linked lists. Again, like so, I'll wait for 2 minutes for more people to join. Meanwhile, those who are watching, please write in the chat. Uh, just a second. Yeah, to write in the chat if the stream is working fine, if you can see me properly. Okay, hi Hemant, great. You're watching Set Theory and Algebra. Am I audible? Am I visible? Am I audible? Is everything working fine? Very good evening. So I'll be starting with the MCQ problems. We will be starting with easy level problems and then slowly go to very advanced level problems. So yeah, it's a gradual increase in the complexity and the problems will be mixed on arrays and linked lists. And do share this like the live stream with everyone you know, like those who are coding enthusiasts and like sitting for placements, you know. This video will be very helpful. It will be a long marathon, like if we have viewers watching, and I'll be solving all the 50 questions live in this video. I will be bringing ML course very soon. and yeah, I'll be sharing that. So very soon, like probably next month, like starting, I will give you information about my ML course. How is it gonna happen? And I will be bringing it along with lots of projects. We will be doing that, Hemant. Right now, like before going to ML, I wanted to focus like a little bit on placements, and that's why I'm covering a few placement related content first, and I'm like calling it cracking the coding interview. So I've already posted one video on this channel which covers top 10 algorithms which are asked in any programming interview. Okay, I've created a video. You can watch that. And today we are going to do MCQ problems. See, any coding interview, how it goes is like, so it's not that you applied on in a company and directly get shortlisted. Generally, for most of the companies, you have to clear a screening round first. In that screening round, generally you're asked MCQ problems in in entire computer science, right? So you might be asked OS problems, OS questions, database questions. Database is the like one of the most popular, and one or two programming questions, so C or C++ or Python. So if you're applying for data science profile, you might be asked Python questions, and then you will be asked data structures and algorithms problems. But generally, in the screening round, you will be asked MCQ problems, okay? Because they just want to check your basic knowledge in computer science before calling you for an interview. So if you crack that particular like screening round, then only you'll get to sit in interviews, and that's why we are solving like MCQ problem scenarios in English. Cool. So let's start. And I want the session to be interactive. I want you to solve problems with me. So I'll give you a problem and I'll wait for like 30 seconds or 1 minute. Do write the answers in the chat, whatever you feel the option is correct. And then let me then I'll solve it in front of you. Okay. So we will start with like slightly basic problems and then we will move to advanced problems. So the first problem is like, what is the minimum number of comparisons required to find the largest element in an array of n elements? Minimum number of comparisons required to find the largest element in an array containing n elements. Think about it and write the choice in like your choice in the chat, and then we will discuss. Okay, I need some audience. Like do share the session with as many people as you can. Then only it will be a successful session. Okay. Minimum number of comparisons required to find the largest element in an array with n elements. So Hemant is saying n minus 1. Like, is there anyone else in the chat? What is the minimum number of comparisons? It doesn't matter, Hemant. It doesn't matter the elements are distinct or not. Think about it. Will it matter if the elements are distinct or not? So, like, why do you need this prior information? That's my question. The better question to ask is the array sorted? Think about it. What is the better question here to ask? If the array is sorted, then probably you don't need to make any comparison. If the array is sorted already, then the largest element will be sitting at the end of the array. So you can directly return it. So it's not about distinct elements. And yes, your answer is correct. It is n minus 1 comparisons. Why? It's very simple. Like since the array is not sorted, like by definition, if it is not mentioned, the array is not sorted. Okay, don't make assumptions. So let's say the array is 3, 5, 1, 2, 4. Take the first element as max, and now compare 3 with 5. If it is larger, then change max. Then compare 5 with 1, then compare 5 with 2, then compare 5 with 4. So here, if the array contained 5 elements, we required 4 comparisons: 1, 2, 3, and 4. So if the array contains n elements, naturally we will be requiring n minus 1 comparisons. I hope this makes sense, okay? So we'll be requiring n minus 1 comparisons. Okay, shall we move forward to the next question? I want more audience in the chat, okay, to be active. Then only I'll be like moving to the next question. So those who have just joined, just say hi in the chat, and then I'll move to the next problem. Also, please share this video with more and more people. It's okay if you have just joined, like you can join the session at any time. We will be solving questions. Okay, we will be solving 50 questions today. Okay, hi, anything. So let's move to the next problem. So the answer to this question was n minus 1. Okay, here is our next problem. In array data structure, what is the biggest limitation which is not there in linked list? Hi, Shashank. So in array data structure, what is the biggest limitation which is not there in linked list? So is it slow access time? Is it slow deletion operation? Is it no random access, or is it the predefined size? So we are playing Kaun Banega Crorepati, like think of it that way. Actually, like coding interviews can make you crorepati. So in some sense, it's a better version of it, because like in KVC you'll win it once. Here you'll win it like every year. What is the biggest limitation of array data structure which is not there in linked list? Predefined size, predefined size. Great, great. It is actually predefined size, because see what, like in array, is the access time slow? No. In array you can access any element in constant time. You can directly write array of 3. You can actually access any element of an array in constant time. Access is actually not slow, it's very fast. Is it the deletion operation which is slow? Actually, yes. Like in arrays, deletion is also slow, right? But there are some ways. There are some ways in which you can optimize the deletion operation. Like you can mask that particular point of the array. In some sense, this option is also correct. But so basically, this option should also be correct, because in arrays, deletion is a problem, like slightly bigger problem than linked list. But also, see, in a linked list also, if you want to delete one particular element, you have to traverse there. So basically, in array and linked list also, if in linked list only the head pointer is given, then also you will require order n time to delete an element. In array also, basically you will require order n like time to delete an element, right? Because you'll have to shift the entire array. So this is not a limitation which is not there in linked list also. Okay. No random access. You can actually access any particular element of an array in constant time. You can do random access. It is not a limitation. It is actually a better thing. Like it's an advantage of using array as compared to linked list. And predefined size is actually our answer, because in array you have to write the size beforehand. You cannot increase the number of elements. In linked list there is no such limitation. You can have any number of like any number of elements in a linked list. That's why it is linked list, right? Like you don't know the size beforehand. You just create node anytime you want. Cool. Let's move to the next problem. So the answer to this question was predefined size. So here is our next question. What is the average case time complexity to delete a specific element in an array? Again, like an easy problem. So the first 10 problems will be easier. Then we will slowly go to the like way more tougher problems. What is the average case time complexity to delete a specific element in an array? Since if you want to delete an element in an array, you'll have to shift all the elements. Just remember that. Come on, write in the chat. Order n, Hemant is saying. I'm repeating again, do share the session with as many people as you can. It's better if we have a interactive session, okay? So like take it as a challenge, like have more people, like take it as a contest. And see, like if you attend this session till the end, like trust me, you'll be having an expertise, you'll have a clear mind coming to arrays and linked lists. Okay? You can basically crack any interview. Cool. So Shashank is saying constant time. Actually, like, see, by definition, in an array, if you want to delete an element, see, sometimes, like, what happens is in interviews, the problem might be ambiguous. But you cannot, like, see, if it is a screening, if it is a live interview with the interviewer, you can ask certain questions to the interviewer to clarify the question more, right? So, but if it is a screening round, if it is an MCQ test, you cannot ask questions, like you cannot ask follow-up questions on the problem which has been asked. You have to answer at that time, right? So take the best possible guess. It might be possible that you have to think what the problem statement, like what the problem setter was thinking. In an array, like if you want to delete an element, let's say you want to delete 5, you might have to shift the entire array. So that by definition, this is what deletion means in an array, right? So you might think like there are better ways to delete elements. Okay, if you're defining an array in some other fashion, like sometimes like what happens is people use like masking bits on elements which are deleted and like just to make deletion faster, but in that case the size operation changes. So like don't overcomplicate things, make like take it very simple. What is like the simplest array, like this is an array of with 5 elements. Now if you want one particular element to be deleted, what will you do? You will just shift all the elements from the right to left one place, so it will be order n time. Okay, don't overcomplicate things, take the simplest possible thing. Try to think and I have taken these problems from like certain sources. Okay, these questions have been asked in some companies, so don't blame me on them. And some of the questions have occurred in exams, like prestigious exams like gate. So actually like companies also prefer to take questions from like which have been asked in gate or exams like that, ISRO or something, because they are trusted and like correct questions. So uh yeah, like I've taken questions from these sources only. Cool. Let's move to the next problem. I hope the solution is clear. Okay, just write in the chat if you don't agree with me or something. Okay, we will clarify it. Okay, let's move to the next problem. How is an n-dimensional array stored in memory? How is any n-dimensional array stored in memory? In memory, is it stored as a 2D array? Is it stored as a 1D array? Is it stored as an ND array? Or is it stored as a linked list? How will you store any n-dimensional array? So in computer, like if you let's say in C program, if you're creating an array, and like let's say 3D array, 4D array, like this. Let's say you're creating 3D array, integer a 3 7 6. It's a 3-dimensional array. Okay. how will it be stored in the computer memory? Okay, Hemant is saying 1D array in row measure or column measure order. Okay. Any more answers? 1D. Okay, actually, great. It is actually one-dimensional array. See, memory is not two-dimensional or three-dimensional. Generally, the memory our system has. So, let's say our system is, let's say, 32-bit. We say, right, 32-bit system, 64-bit system. If your system is 32-bit, what does it mean? That any memory address can be written in 32 bits. So you have, like, from 0, you will have 2 to the power 32 minus 1 memory locations. So memory location will always be an array. Memory is always an array, 1D array. So even if you're creating a 2D array, let's say, if you're creating a 2D array of size 2, 3, 6 elements. So you have 2 rows and 3 columns. You want this matrix of size 2 cross 3, but still the in memory it will be stored by flattening it only. So, and yeah, you were correct, Hemant. Like it will either be stored in row measure order or the column measure order. Okay, so either you will store them like this row first and then this row, or this column, and this column. Okay, either the row measure order or the column measure order. So it doesn't matter how many dimensional array you are creating. In memory, it will always be stored as a 1D array. Okay, it will automatically flatten it. Cool. Let's move to great going, guys. Let's move to the next problem. Question number 5. Which data structure is used to find the least frequent element in an array? You have to find the least frequent element in an array. The element which is present the least number of times. Will you use a hash map? Will you use a stack? Will you use brute force? Or will you use linked list? Again, those who have just joined, it's okay. You can just continue learning from here. We will be solving 50 problems on arrays and linked lists today. Do share this session with as many people as you can. Like, let's make this session highly interactive. Okay, Hemant is saying hash map. Any more guesses? How will you find the least frequent element? Frequent means like सबसे कम बार है उस array में. So for example, like let's say this is your array. Three, two, three, two, two, one, 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 two. So in this array, 1 occurs 3 times, 2 occurs 4 times, and 3 occurs 2 times. So 3 is the element which is least frequent. 3 is the element which is least frequent. Its frequency is least. How will you find the element with least possible frequency? See, you want to find the data structure. You want to find the data structure which will be used to find the least frequent element. Okay. First thing, brute force is not a data structure. Brute force is algorithm, right? Brute force is something which you apply. So this is definitely not true. Using a stack, it is not possible, right? Because like what will you do? Like let's say you are appending the elements in a stack, 1, 3, 2. It doesn't matter, like right? In a stack, you will not be able to count the frequency. How will you count the frequency using a stack? It's very difficult. Using a stack, it is not possible. Okay, stack is what? Stack is first in, last in, first out. Right. It doesn't make sense. Like how will you count? Like how many times? Also link, so also like hash map is the correct answer. Why? Because we can actually create a hash map key which will store the frequency of every element which is like there. Right. So let's say we create a hash map and I'm just storing the count. Right now it is 0. And every time I'm finding a new element, I'll just update the count by 1 and so on. So for every element, this is actually the hash map only, right? This is the hash map. Hash map is a key value pair. Like you are associating. So for every value present in that array, in that particular array, you are just counting how many times it is present. So using a hash map, you can actually find out like which element was the least frequent element. You can, Hemant, yes, you can create a frequency array as well. You can create a frequency array as well, but it is not like necessary. Like you can, uh, but you can use hash maps as well, right? In the given options, you cannot use a linked list. You cannot use a like brute force is not even a data structure. You cannot use stack, right? You can use hash map to count. So given these options, hash map is the correct choice. Hi Kumar, welcome to this session. Uh, you can continue watching from here only. We will be solving like 45 more problems on stacks. Sorry, on arrays and linked lists. Cool. So the correct answer is hash map. Just write in the chat box if you have any doubt. Okay. I'll be moving forward to the next problem. Okay, this is our next problem. This is on linked list now. Which of the following points is or are true? Which of the following points is or are true about the linked list data structure when it is compared with an array? Arrays have better cache locality that can make them better in terms of performance. It is easy to insert and delete elements in linked list. Random access is not allowed in a typical implementation of linked list. The size of the array has to be pre-decided. Linked lists can change their size anytime. Which of the following points are true? So this will like clear lots of points. Yeah, it is an MSQ. Like consider it a MSQ. Actually, arrays have better cache locality. Like think what cache locality might mean. So this is a concept from computer architecture. This is a concept from computer architecture. And what would be your answer, Hemant, if this is not an MSQ and an MCQ, like single correct? Yeah, I will explain what option A is. Okay. So any other people in the chat, like any guesses? Okay, so let me explain. The correct answer is all of the above. Actually, all the options are correct. Ganesh is saying C and D. Okay, that's okay. Okay, I'll explain. So arrays have better cache locality, and it makes them better in terms of performance. This is correct. Why? See, what is cache locality? You might have heard ki generally, like in computer architecture, what happens is caches are organized in terms of levels. So you will have L1 cache, then you will have a slightly larger L2 cache, then you will have a slightly larger L3 cache, then you will have memory, RAM, then you will have hard disk. Right? This is how generally memory is organized. This is how generally memory is organized. So what happens is, if you want, let's say, small portion of, if you want to refer something to some memory address, if you want to refer to some memory address, you find it in L1 cache. If it is not present here, you get it from L2 cache. If it is not present in L2, you find it in L3 cache. So firstly, it will be copied to L2 cache and then it will be copied to L1 cache. And if it is not found in L3 cache, you will go to RAM. If it is present there, you will get it to L3, then L2, then L1, and then like to registers. Finally, they have to go to registers, right? Everything like in computers work with registers. Like you want to add something, you will get them in one register, another register, add them. So on very low level, everything will be happening on registers, but this is the flow. And what happens is, let's say register wants to get memory location 201. You want to get memory location 201. If it is not present in L1 cache, you will search L2 cache. Let's say 201 was present in L2 cache. Generally, you don't get only one like memory location. So when you are trying, so this is called cache hit and cache miss. So if you are incurring a cache miss, generally you will be looking for one memory location, right? So basically in RAM, like you want whatever is present at memory location 201. It was not present in L1 cache. You're going to L2 cache. In L2 cache, let's say 201 was present. Like whatever 201 address contained, it is present. So generally what happens is, you won't be copying just 201. You will be copying 202, 203 also. Generally, you will be copying one block of memory entirely to L1 cache. So like these caches are organized in blocks, right? And you copy entire block of memory. So why is it so? Why is it so? Generally, all the operations in any computer program, they happen on sequential memory locations. So what computer thinks is, computer will think ki if you use memory location 201 now, it is highly likely that you will be using memory location 200 and 202 also very soon in the computer program. This is called a general phenomena, like this is a very general phenomena in computer science, and it is called locality of reference. Locality of reference states that if you are using a memory location right now, it is very likely that your computer program will be using memory locations near to it in near future. So that's why, see, arrays, I told you one thing about arrays. Arrays are always stored in continuous memory locations. Arrays are always stored in continuous memory locations. So it is always better. So arrays like so. And what happens is, if you are having a cache miss, generally an entire block of memory will be copied to another level of cache, right? So what will happen? Like 2 or 3 or 4 like continuous memory locations, or 2 or 3 or 4 continuous elements of the array will be copied to L2 cache or L1 cache. So that's why arrays will have better cache locality as compared to linked lists. Why? Because linked lists are stored at here and there. Linked lists, like they are not stored in continuous memory locations. One node is present in memory location 100, other might be present in memory location 100 and might be present at memory location, let's say 205, 204. Another might be present in memory location 8, and so on. So they are not very good in terms of cache locality. Like generally, linked lists don't follow locality of they are not present in continuous memory locations. That's why they are like cache locality. The concept of cache locality is not applicable on them, and arrays have better cache locality, and it makes them better in terms of performance. Okay, do write in the chat if you understand this point. Coming to the second option, it is easy to insert and delete elements in linked list. Yes. See, let's say somebody tells you to insert an element at the third position in an array. See, like complexity wise, it will be order n only. Complexity wise, like generally speaking, like insertion and deletion in an array will be order n, and in the most general implementation of linked list also, you might have to traverse to that particular element and then delete it, or like if you want to insert an element also, like complexity wise it will be order n. I agree, but like generally speaking, see, yeah, this is again an ambiguous option. Complexity wise, insertion and deletion in both arrays and linked list will be big of n. I agree. But generally, like what will happen again, we are solving it with placement point of view. In placement, definitely, like you will, like, I know this option is ambiguous. Option C and D are definitely correct. A, C, D are definitely correct. So if it is a single correct option, you should like definitely select all of the above. That and there is a reason behind it. It's not that ki option B is completely incorrect. In linked list, it is slightly easier to insert and delete elements. Because why in array, if you want to insert an element at third location, you will have to shift the entire array by one location. You will have to shift the entire array by one location, and it might even be possible ki let's say the array was of size 4. Array is of size 4, 1, 2, 3, 4, and now let's say you want to insert 5 at third index. You want to insert 5 here. That is even not possible because the array like limit is already exhausted. So then generally what people do is people create dynamic arrays. What is a dynamic array? If the array's size is full, you will again take an array of size twice the memory. So you will take an array of size 8 and then you will copy all the elements here. Then you will write 5 here and then 3 here and then 4 here. So it will take like extra space also, like twice the size, and it will take more memory, like time also. In generally linked list, if the pointer to the correct node is given, you can insert or delete in constant time, at least, right? So I agree, like only if the element is given, it will take more time. It will take order n time only. But in linked list, at least the insertion and deletion don't take, like you don't have to shift. Like elements. Basically, like in arrays, you will have to shift the entire array. And it is even possible that you might have to create another separate array completely. So actually, like it is slightly easier to insert and delete elements in linked list. I hope this makes sense. Okay. Coming to option C, random access is not allowed in a typical implementation. Correct. In the typical implementation of linked list, this will look like this, and you cannot have a random access to any element. You will have to traverse. Option D is the size of the array has to be pre-decided. Linked list can change their size anytime. It's like very much correct. Very easy option. Do let me know in the chat if you agree, okay? And I completely agree with you. Complexity wise, insertion and deletion in the classical implementation of linked list also will be order n. So it's okay if you are skipping option B. Complexity wise. Okay. So we have some questions in the chat I'll like to address. It's about placement in IIT Bombay. The question is, does algo trading companies like Graviton or Tower Research? Yes. Generally, most of the generally, like, yeah, I agree with your doubt. Like it's a good question because HFTs generally prefer BTech students, but it's not always the case. Like 1 year back, like just before our batch, like Tower Research actually opened for MTech students also. Okay. So few HFTs also, Alpha Grab generally opens for MTech students also. So and APT portfolio opens for MTech students also. So like few HFTs do open for MTech students also. A few HFTs might not, but like don't worry about the placements, okay? Like anyways. Cool. I hope this answers your question, Pranav. Like, let me go to the next problem. This is question number 7. What is the optimal time complexity to count the number of nodes in linked list? Or rather, it should not be optimal actually. Like, what is the average time complexity? Let me change the problem for you. What is the average time complexity to count the number of nodes in a linked list? And again, like if nothing is given, consider the classical implementation. What do you mean by classical implementation? Like the ये वाला implementation. You will have a node, the data, and a pointer to the next node. You will have the data and the pointer to the next node. You will have the data and the pointer to the next node, and so on. It is a singly linked list. By default, always assume singly linked list. So if you have to count the number of nodes in a linked list, you will have to traverse the entire linked list. It's a fairly simple problem. Traverse the entire linked list, take a counter, increase it by 1 in every iteration. You will be able to count the number of elements. Okay, big O of n. Do write me in the write in the chat if you have doubts. Otherwise, like I'm assuming you got it. Like correct Ganesh, correct Hemant. It is big O of n. Cool. Let's move to the next problem. What are the time complexities of finding the 8th element from the beginning and the 8th element from the end in a singly linked list? Assume that n is very, very large than 8. What are the time complexity if you want to find the 8th element from the beginning and 8th element from the end in a singly linked list? And assume that the linked list contains a large number of elements. बहुत सारे element है. The number of elements, let's say, is large, very, very large than 8. What are the time complexity to find the 8th element from the beginning and 8th element from the end? So Hemant and Ganesh are saying option A. Cool. No, Hemant, you cannot generalize for kth and n minus kth. I'll explain why. Cool. So generally, like if n is very large, to find the 8th element from the beginning, generally, like again, generally speaking, when I say generally word, it is like the classical implementation of linked list, in which you will be given the head pointer. So assume that you are given the head pointer. And now you want to find the 8th element from the beginning. What will you do? So this is your first step element, traverse, go to the next element. But when I say traverse, it is like you are taking a temporary array and you are just storing temporary ka next in temporary. So it's like going to the next element, right? So slowly you will go to the 8th element. Let's say this is your 8th element from the beginning. So it will take exactly 8 operations. So if you want to find 8th element from the beginning, it will require you exactly 8 operations. Now, since n is very, very larger than 8, we can say that 8 is nothing but constant time. Generally, this is how constant time is defined, right? Constant time का मतलब ये नहीं है, big O of 1 का मतलब ये नहीं है कि it should require exactly 1 operation. No. Anything like which is like countable, like very small, right? Even order of C is order of 1 only, constant time. Like if it is constant, like that's how it is called constant time. Like it is always constant. We will take 8 operations. So that is why it is big O of 1. But if you want to find the 8th element from the end, you will have to traverse the entire linked list, because 8th element from end will be somewhere here. These are 8 elements. Will be somewhere here. You will have to traverse the entire array, and actually you will have to do 2 passes. Because you will not know the value of n. You will not know the value of n. By default, you will not know how many elements are there in the linked list, right? So firstly, you will count all the elements in the linked list. And then you will do another pass to find k minus nth, like n minus 8th element from the beginning. 8th element from the end is n minus 8th element from the beginning. So then you will again do another pass. Or what you can do is, you can actually store the last 8 elements every time. Just store the last 8 elements which you have seen every time. And then so when you have hit the end, the last 8th element will be your 8th element from the end. Okay. In any case, you follow any strategy, you will require order n time to find the nth element from the end. So option A is correct. Now coming to Hemant's question, can we generalize it for any k? No. See, if you are taking k, like kth element from beginning and kth element from end, you will have to see how big is k. If k is very small, if k is very small than n, then generally speaking it will be constant time, right? Like see, anyways it will be order k. If you're talking about kth element from beginning and kth element from end, it will be order k time to find the kth element from beginning, right? Because you require exactly k operations, and you will require order n time to find nth element from the end, kth element from the end, anyways, right? So you like yeah, for kth element you cannot say big O of 1 and big O of n. It should be rather big O of k and big O of n, I would say, right? Cool. So this was our 8th question. Let's move to the next problem. The concatenation of two lists is to be performed in big O of 1 time. We want to perform the concatenation of two lists in constant time. Which of the following implementation of a list should be used? I want to concatenate What do I mean by concatenate? See, generally, like all of these are linked lists. So let's say I'm given two lists. This is my one list. I'm given head pointer. This is head pointer. And this is another head pointer for another list. And let's say I want to concatenate these two lists. What do I mean by this? I want to add all the elements of head 2 or the second list at the end of the first list. So I want this particular pointer to be established basically. Or sorry, it's the other way around. I want this particular pointer to be established. That's what I want. Which implementation of linked list should we use if we want to do this task? Okay, so C, all of us are agreeing on C, I guess. So it is actually C, correct? C, if you have a singly linked list, what is singly linked list? Like this only. Every node is connected to another, like the next node. If you have a singly linked list only, if you want to establish this connection, if you want to establish the first node like this, we want to basically establish this connection. The last node of the first list, I want to connect it to the first node of the second list. So if it is single linked list only, single linked list is what? Like linked list of this type, in which every node stores the pointer to the next node. That's it. So what happens is, if you have singly linked list, it will take order of n time, if n is the number of elements in the first list, to go to the last element. Then only I can make this connection. So it will take order n time to go to the last element, right? So in singly linked list, it is not possible. What is doubly linked list? In which every element stores 2 pointers, pointer to the next node and pointer to the previous node. So let's say this is our first list and this is our second list. Now generally what happens, again you will be given the head pointer only, head 1 and head 2. So still if you want to make this connection, still, so here if you want to do concatenation, we will have to make two connections. One this and one this. Then only it will be concatenation, right? I want to make these two connections. Anyways, I will have to go to this element, the last element. To go to this element, I will again require order n operations because I am given two heads only. So I'll have to traverse to the end of the first array. Anyways, we will again be requiring, so here also big O of n time, here also big O of n time. But in a circular list, the things are much simpler because see, this is circular doubly linked list. Here, this is circular doubly linked list. Amazing. So what will happen? So let's say this is our first linked list. And let's say this is our head pointer h1. It points to this node. Okay, this is the head of the first linked list. And let's say I create one more linked list h2. So this is the head pointer of another linked list. This is the first node. This is the second node. And this is the third node. So I basically, let's say I number the elements as well. 1, 2, 3, 4, 5, 6, 7. So by concatenation, what do I mean? By concatenation, what essentially do we want to do? We want to convert both these to a single combined linked list. So by concatenation, what do we mean by concatenation? I want to append 5, 6, 7 at the end of 4. So it should be 1, 2, 3, 4, 5, 6, 7. And then 7 should be connected to 1. So how can you do that? Basically, after 4, I want 5. So I want to make this connection. After 4, we want 5. And fifth, so basically this connection also, because it is circular doubly linked list. So we want to connect 4 to 5 and 5 to 4. So this connection has to be removed. This connection has to be removed. And this connection has to be established. And also, after 7, I want 1. After 7, I want 1. So these connections have to be removed. And 7 has to be connected back to 1. So this connection has to be established. Right. But anyways, actually, see what happens is, since the head pointer to both the list has been given, let me make it slightly, like, let me make some space here. So what is happening is, again, let me take the same linked list, okay? You are given circular doubly linked list. And another circular doubly linked list. And you're given two head pointers, h1, which is pointing to this node, and h2, which is pointing to this node, and they are numbered 1, 2, 3, 4, 5, 6, 7. So I want two connections to be made. Actually, like, lot of pointers will be affected, but what do we essentially want? We want कि 4 के बाद 7 आना चाहिए. 7 should come after 4. What we will do? See, how will we go to 4? See, since it is a circular and doubly linked list, you can always go to the previous node also, since it is W also. So you can always go to the previous node of H1, which will be this node. So go to this node, and also you can go to the last node of this particular. So after 4, we want 5 to come. So basically we want the first element of the second linked list also, which is anyways present at head. So what we will do, we will go to the last node of this node of the first linked list, and we will make the appropriate connections. So we will remove these connections, and we will make the next of this 4 to be 5, and also we will make this wala previous of 5 to be 4. Okay, and similarly, I can go to the last node of the second linked list also in constant time. Since I have actually, see, it's very fairly simple problem. We can go to any node, last node or the first node in constant time for both the linked list. So I hope this makes sense. So for to make the other two connections, what we will do, I will go to the last node of the second linked list, which is node 7, and I will make these two connections. So I can actually do all these 4 connections in constant time. Okay. See, it would have not been possible in if the linked list was just circular, it is not possible. Think about it. Only in circular doubly linked list we can do this concatenation in constant time. Think about it. Okay. Okay, let's move to the next problem. What is the worst case time complexity of inserting n elements? What is the worst case time complexity of inserting n elements into an empty linked list if the linked list needs to be maintained in sorted order? You have to maintain the linked list in sorted order. Then what is the worst case time complexity to insert n elements in a linked list? Okay, think about this problem. I'm just taking a 2-minute break. I'll just bring water. Okay. Hello, hello. Okay, do let me know in the chat if I'm audible and visible again. So the linked list needs to be in sorted order. Okay, great. Thanks, Hemant. So yeah, actually your choice is correct. It is big like theta of n square. Why? Because See, we don't know. Like, let's say the first node we created was 3. This is our head pointer. This is our head pointer. First node we created was 3. Now I want to insert 5. So I will go here. Is 5 greater than 3? Yes. So I will go to the next element. There is no next element. So I have reached the tail. So I will basically insert 5 here. Now let's say if I want to insert 4. Now I want to insert 4. So I will compare 4 with 3. Is it greater than 3? Yes. Then I will compare it with 5. Is it greater than 5? No. So basically I have to insert it between these two elements. So basically I will create a new node 4 and I will just establish this connection. So every time when you're inserting a new element, you have to traverse the entire linked list. Every time you're inserting a new element, you have to traverse the entire linked list and find the correct location where you want to like put that element, right? So the linked list contains, let's say, 6 elements, and you want to insert a 7th element. You will have to go and traverse. You will have to go and traverse and find the particular location where this element has to be put and make these 2 pointers, right? So it will be big O of n operation every time you're inserting an element. So for the first element, it is like 1 operation. For the second element, it will be 2 operations. So it will be 2 comparisons. For the third element, it will be 3 comparisons because there are 3 elements. And so on. For the nth element, there will be n comparisons. So it is big O of n square. It is basically n plus 1 by 2, right? So it is big O of n square. Okay. So let's move to the next problem. So remember I told you about dynamic array. What is a dynamic array? You take an array of some size, let's say 5. If these 5 elements fill up, if you want more size array, what will you do? If you want to insert one more element in this array, you will create another array of size 10 and copy all the elements. If this is also filled up, you will create another array of size 20 and so on. So once the array gets filled up, you create another array of size twice. If the previous array was of size x, you will create another array of size 2x, and then you will like copy all the elements of the previous array. So in a dynamic array, what is the worst case time complexity of inserting a new element? Anyone in the chat? Option C, option C. Great. It is option C. Why? Because again, the same logic, okay? Let's say you already have an array. You defined a dynamic array of size 5. You defined a dynamic array of size 5. You filled all the elements, let's say 1, 2, 3, 4, 5. Now you want to insert one more element 6. What will you do? If it is filled completely, you will create another array of size 10. Okay? And then you will copy all the elements of this array. And then you will insert. So it might take order n time in worst case to insert an element in a dynamic array. It's correct. Okay? Okay, let's move to the next problem. To move all the negative numbers to the front of an array, how many traversals of the array are needed? You want to move all the negative numbers in an you are given an array. You want to move all the negative numbers to the front of the array. How many traversals of the array are needed to do this task? How many times will you pass the entire array to do this task? Yeah, actually, one is correct. You can do this in just one pass. So how can you do it? Using two pointers. Let's say this is your array. 1 minus 3, 2 minus 1, 0 minus 4, 6 and 7. So what will you do? You will take two pointers, one and another. So basically you will swap the elements, if you find a negative element. So the other pointer is just storing the location of the first positive number. That's it. Okay. So let's just move the first pointer. You're at minus 3. Since this is negative and this is positive, you will swap these two. So you will have minus 3 here and 1 here. Then you will move this pointer also. Okay. Every time you swap, you move the second pointer also, because the second pointer is just storing the location of the first positive element. The second pointer is just storing the location of the first positive element. Now again, this is so let me like do it like in a slightly better way. Okay, my application is hanged. Okay, let's do it like this only. First positive element. So OneNote doesn't support lot of undos, it seems. So this is your second pointer and this is your first pointer. First pointer is black, second pointer is green. So second pointer is basically storing the location of the first positive element. So now you swapped and then you'll again move the second pointer. First pointer basically. So if you're getting a positive element, don't do anything. If you're getting a negative element, again swap these two. So this will become -1 and this will become 1. And again move the second pointer here. Again this is pointing to the first positive element. And so on. You keep doing this. Again you will find -4, you will swap it with 2. So this will become -1, -4, this will become 2. See, you don't care where the positive elements go. You don't care where the positive or zero elements go. You just want all the negative elements to be in the front. So this will happen with this strategy. All the positive or zero elements will go at the end and all the negative elements will come to the front. So you just need one traversal to solve this problem. One traversal of the entire array. So let's move to the next problem. This is our next problem, question number 13. A program X reads about 800 integral values in the range from 0 to 100, representing the marks of 800 students in a class. Now it has to print the frequency of each mark above 50. You have to find like by frequency, what do we mean? We have to find like how many students scored 51, how many students scored 52, how many students scored 53, and so on up to 100. What would be the best size of an array of X? What would be the best size for an array for this program X you will take to store these frequencies? Will you take an array of size 50? Will you take an array of size 100? Will you take an array of size 800? Or will you be taking a dynamic array of size 850? Come on, like answer in the chat, guys. So Hemant is saying A, and A is actually correct. See, you want 800 values. So like there are 800 students. There are 800 students. It doesn't matter. Student 1 scored 73. Student 2 scored 13 marks. Student 3 scored 66 marks, and so on. So we have 800 students. 800 the student scored, let's say 92. What we want is we want the frequency of every score above 50. We want the frequency of every score above 50. So we want the frequency of 51. We want the frequency of 52, and so on. And we want the frequency of 100 marks. Frequency means how many times it happened. So that's okay. You just need to store an array of size 50. You just need to store an array of size 50. That's it. This is the array you want. You might claim ki, like, what about index? The array is 0 indexed. So you might say it is an array of size 100 also, but you don't need it. Let's create an array of size 50 only. It doesn't matter, it is 0 indexed. Let's say at index 0 you are actually scoring the frequency of 51 marks. At every index I you are storing the frequency of I plus 51 marks, let's say. So basically you will traverse to all the students, you will check their marks. If their marks are 73, you will increase the counter at location 73 minus 51. You will increase the counter at the location 73 minus 51, and so on. At the end you will have the frequency of all the scores which are greater than 50, right? So you just need an array of size 50, that's it. Ganesh, it will take like it takes about 6 months, okay, to be a good programmer. Like you need to do a lot of things. You need to improve data structures algorithm. So you'll have to do a lot of practice on CodeChef, like and code forces, like these type of websites. And then only, like, so it will take, like, generally in 6 months you'll be a decent programmer. So like start early and like solve at least 1 or 2 coding problems every day. Cool. So let's move to the next problem. Question number 14. Which operations cannot be done in constant time for an array of sorted data? You're given an array with sorted numbers. You're given a sorted array basically. Which of the following operations cannot be done on this array in constant time? Hi, Sarvesh. Which of the operations cannot be done in constant time for an array of sorted order? Correct. It's C, deletion of any element. So let's take an array which is already sorted: 3, 5, 7, 13, 23. You want to print the nth largest element. It can be done. So these are the array indexes. These are the array indexes 0, 1, 2, 3, 4. If you want to print nth largest number, can you tell me? Let's say the array. I'm asking a question. Let's say the array is of size k. The array is of size k. The length of the array is k. You want to find the nth largest number. What will be the index? What will be the index of the nth largest number in this array? The array is of size k. It contains k elements. What will be the index of the nth largest number in this array? Nth largest, not the first largest, Sarvesh. You want to find the nth largest number. You're right, actually. For the first largest number, it will be at index k minus 1. The first largest number or the largest number will be at index k minus 1. The second largest number will be at index k minus 2. Right? This will be your largest number. This will be your second largest number, third largest number. Where is your nth largest element? Which index? Actually, like, it's just progression. It's just k minus n only. See, the first largest element is present at k minus 1. Second largest is present at k minus 2. Index. I'm talking about index. Okay, I'm talking about index. I'm not talking about the position. The position k minus n plus 1 is correct, but the index is k minus 1, k minus 2, and the nth largest will be presented k minus n. First largest at k minus 1, second largest at k minus 2, nth largest will be at k minus n. So you just directly, if you want to print the largest element, you just directly print a of k minus n. Similarly, if you want to find the nth smallest number, if you want to find the nth smallest number, so the first smallest number is presented at index 0, second smallest number is presented at index 1, and so on. So the nth smallest number will be presented at index n minus 1, a of n minus 1. This is your nth smallest number in the array. If you want to find the smallest element, it's definitely a of 0. It will always be the smallest element. So these are all constant time. But if you want to delete an element, you will have to delete it and shift all the elements after it. So it will take order n time. So order n is correct. Let's move to the next problem. Just do write in the chat if you have any issues. So this is the next question, question number 15. What is the minimum number of comparisons required to determine whether an integer appears more than n by 2 times in a sorted array of n integers? Okay, cool, Sarvesh. Like, do share this channel and like this video with everyone, you know. Like, let's make this channel viral. Okay, let's. So, what is the minimum number of comparisons required? Moore's voting. You're making a slight mistake. Hemant, read the question again. You're right. It is n minus 1 if you do Moore's voting. And then, yeah, then it is correct, sorted. Okay, so I lost. It's very common to make these type of mistakes. I lost two, two, 3 marks. 3 marks in gate exam just for a single word, uniform distribution. Okay, and like it's like crazy. It is possible. So it's like sometimes like it becomes kind of trick question, right? Because you're seeing this n minus 1, you know Moore's voting algorithm. You apply that, it will take n minus 1 comparisons to give you that element. But actually they have given you sorted array. They have given you sorted array. So if in a sorted array, if you want to find an element which appears more than n by 2 times, right? So why only C? See, like what if I add an option of constant time only? What if I add an option of constant time also? think about it, like it's very intuitive to like think about it, like you want to find an integer which appears more than n by 2 times. Actually, like if the element is guaranteed to occur, it's a slightly controversial question. I feel like this has been asked in Git as well, and it's a slightly controversial problem. Like I feel like, see, if you're given the array in sorted order, if you're always given the array in the sorted order, then the element which is present more than n by 2 times should always be present in the middle. Am I not right? See, why? Because like if let's say this array has n elements, if the array has n elements, actually yeah, this is correct. It should be like constant because the reason like yeah, can you give me an example, Hemant, where this won't work? Can you give me an example where this won't work? So if you're given n elements, let's say this is the first half, like so if an element, see, it doesn't matter. If it is occurring more than n by 2 times, so if so in the sorted order, what will happen? Let's say the element is 1. Okay. Let's say the element is x. And if x is present from the beginning itself, if it is present more than n by 2 times, definitely the middle element will be x only, right? Because this is x by 2. This is n by 2. Since it is present more than n by 2 times, the middle element has to be x. And similarly, like if you slide this window all the way up to end, it doesn't matter. Like if one particular element is occurring more than n by 2 times, it has to be in the middle, right? Why won't be in the middle? So Hemant is giving us an example. If the middle has 3 elements before mid, one mid, and one after mid. Okay, you're giving us an example. Let's say n is equal to 10. That's great. So I'm creating n is equal to 10. In middle, 3 elements are there around mid. So this is our middle. Let's say the index number 4 and 5. These are our middle elements. So I still didn't get your point. Like let's say you have 3 elements around mid. Like what does this mean? So let's say here we have 5, 5, and 5. See, in this case, what will happen? In this case, you won't have any element which appears more than n by 2 times. In this case, you won't have any element which appears more than n by 2 times. Right? If that element is sure to happen, see, like if the problem is slightly controversial. Why? If they write this thing in question, ki if they write this thing in question, ki that element definitely exists. The element definitely exists which appear more than n by 2 times. That particular element definitely exists. Then we are sure ki it will be present in the middle. But what if the element doesn't exist? What if the element doesn't exist? Right. So that's where this question becomes like controversial. If you're guaranteed that an element will exist that will appear more than n by 2 times and you have to find it, then it will be constant time because it will be the middle element. But what if the element doesn't exist? You need to find out, like you need to check ki it is existing or not. then it might be possible that you are just firstly to check कि an element exists or not, you are traversing the entire array. You don't need that. Since the array is sorted, if you want to check, you can just apply binary search. You can just apply binary search to find an element appears n by 2 times, like more than n by 2 times or not. Because at the half of the array, all the elements at right should be the same element. So you just need to check the middle element and then again the middle element and so on. So it will take only log n time to verify. It will take only log n time to verify, right? So in that case, like if it is not given, then it will take log n time to verify that an element appears n by 2 times or not. Otherwise, if it is given, then it is constant time only. Okay. So there are two like answers possible to this question. I hope you got it right. Okay, next question. Really, really, really simple question. What is the correct way to declare an array? What is the correct way to declare an array? The most easy problem, like option A, correct. Integer hello 10. This is not correct. This is not an array. This is just an integer. This is not correct. This is not even anything. This is also not correct. Array is not a keyword. NC. Okay, so option A is correct. Cool. Let's move to the next problem. Again, a very simple problem. Array elements are stored in dash memory locations. I have told you this thing many times today. Sequential memory locations. Doesn't matter you are creating a 2D array, 3D array, 4D array, ND array, कुछ भी बनाओ. Memory locations are always sequential. Memory locations are always a 1D array. So the array elements will be present in a sequential fashion. Let's move to the next problem. I'm having a few filler questions, like very quick questions. So, okay. What is the maximum number of dimensions an array can have in C language? What is the maximum number of dimensions an array can have in C language? Dimensions. Hemant, on YouTube only I have covered discrete maths almost completely, right? The only thing which I didn't cover on YouTube was linear algebra. Apart from that, I have covered the entire discrete maths. Actually, like that is even in engineering maths. Discrete maths are fully covered. Even in engineering maths, I remember I covered probability and statistics. Okay, I'm not sure. You can check. And if you're a plus member, then it's great. Like, yeah, on plus, I covered entire discrete maths, combinatorics, graph theory. I even forgot the subject names. Okay, I covered entire discrete maths, and in engineering maths, the only thing left was linear algebra. Otherwise, like you'll find everything. Okay, I was not able to finish linear algebra back then. Cool. So, Sarvesh, why two? Why two? There is no limit in C or C++. Okay, you can create any array of any dimension. You can keep adding dimensions. The only thing is you might exhaust all the memory. You keep creating dimensions, and you don't even have enough memory. Okay, then the program will be like halted, like it will be destroyed. So yeah, and generally the language imposes no limit. Okay, let's move to the next problem. Here an array is defined. You're defining an array of size 10 and you're initializing it with 1, 2, 3, 4, 5. Now you want to print what is present at array of 5. What is present at array of 5? So when you are initializing an array, when you are initializing an array, when you are initializing an array, it automatically always gets filled with zeros if you are not initializing it fully. Okay, that's an important concept. So that it's this was still a trick question. Lot of people might think it is garbage value. Okay, why? Because you created an array of size 10. This is an array of size 10, and you initialized it with 1 2 3 4 5 only. You left all these places empty. You didn't write anything. So if you're doing an incomplete initialization of array, always remember, if you're doing an incomplete initialization of array, it will automatically fill them with zeros. It will like generally, like when we create an array or when we create a variable in C or C++, it is always initialized with garbage value if you're not doing it. But if you're doing an incomplete initialization, it will automatically fill it with zeros always. So at fifth location you will have 0. Okay, it was a trick question. You should know this small concept, okay? But for interviews it is like useful to know. Okay, now let's move to the next problem. Similar problem. Yes, option A is correct. Most of you are saying option A, and actually it is correct. See why? Here there is no backfilling, okay? So what happened was you created an array of size 10. And you didn't initialize it at all. Anyways, even if you had initialized it with, let's say, 1 2 3 4 5, it doesn't have mattered. It didn't have mattered. If you have initialized it with 1 2 3 4 5, let's say, what will happen? You will have 1 2 3 4 5 here, and it will automatically fill zeros here. It doesn't matter. What is A? A will always point to the first memory location of an array. The name of the array is always the first memory location. What is A minus 1? This is A of minus 1. So you don't know what is present at this memory location, but you can still refer it. C won't, the programming language won't stop you. Okay, and the same thing for A of 12. And actually you're right. Actually you're right. For A of 12, it will show array out of bound. It will show array out of bound. Okay. So actually, like, the ideal answer should be none of these. Okay, you are trying to access a memory location which is out of bounds. But like in one of the languages, C or C++, it doesn't show array out of bounds error. I forgot like which language. You can just check online. Like even I forgot. But it won't show array out of bound. It will just print garbage. Okay, it won't like show you the error. In Java and Python, it will definitely show array out of bound if you're trying to access array indices like which are not defined. Cool. So like you can check like which languages support which, but ideally like this question should not have been asked without specifying the language, like which language you are running it in. Cool. Let's move to the next problem. In worst case, what is the number of comparisons needed to search a singly linked list of length n for a given element? So you want to find You want to find a single element. You want to find a single element in a single linked list. Okay? Like the language is slightly tricky here. Even like I have to read it again. You have to find an element in a single linked list. In worst case, what is the number of comparisons you might have to make? Very simple question. You might have to traverse the entire linked list. Very simple question. You might have to traverse the entire linked list, right? The linked list contains n elements. You have to find one particular element. In the worst case, it might be present at the end of the linked list. You want to find 1, 5, and 5 is present at the end. So you might have to traverse the entire linked list and then you will find it. So in worst case, you might have to make exactly n comparisons to find the last element. Correct? All of you correct. Okay, in the chat. Let's move to the next problem. Oh, it's an interesting problem. I'll give you some time to think about this problem. So this question is not very easy. Okay, try to see what the code is doing, and I'll just take a 2-minute break again. Okay, I'll be back. Just try to solve this problem, and then we will discuss what this problem does. Okay, great. Let me know in the chat if I'm audible and visible again. Great. So I see different options in the chat. Only one of them can be correct, right? So I see C and B. Okay, you have a linked list. 1, 2, 3, 4, 5, and 6. You have linked list 1, 2, 3, 4, 5, 6. You want to do this thing if start null and otherwise. So you are given start here. So start will be pointing to 1. This is your start. So then like you will print start ka data. So you will be printing 1. Now you are saying if start next is not null, so start ka next is not null. So you are again calling the same function solve with start ke next ka next. So you are basically making this start. You're making this start. And again, the same thing will happen. Start is not null, so you will be printing this data 3. Then you are again like calling the same, still start is not null. So you'll again call the solve function with start ke next, which is 5 as a start. So again, you will be, again, start is not null. So you'll print the start ka data, which is 5. And again, start ka next is not null. Yeah. So you will again call start ka next, which is actually null. So now start is null, so you will return. So when you return, you will again be printing this data again. So for this, you will be printing the data again. For this, you will be printing the data again. For this, you will be printing the data again. It is like stack. Recursion works like stack. So whatever was called first now will be called last. So yeah, like that is the classical recursion stack. And you will be having 135, 531, which is B, which is option B. Okay. Cool. Let's move to the next problem. Insertion of an element at the middle of a linked list requires the modification of how many pointers? How many pointers are needed, like needed to be modified if you want to insert an element in the middle of a linked list? How many pointers do you need to change? Option A, 2, correct. So what we will do, we will have a linked list. We want to insert an element in the middle. Let's say I want to insert an element here. So I just have to make 2 corrections. Firstly, I want to change this pointer and then I have to change this pointer. That's it. So it will require 2 pointer modifications. A very similar problem is coming up. For how many pointers will change if you want to insert an element at the end? If you want to insert an element at the end. Yeah, if it is doubly, then it is 4, correct, Hemant? We have a very similar question, question number 24. How many pointers will be modified if you want to insert an element at the end of the linked list? Last ka null is not a modification, right? Like, so yeah, actually. So null set karna is not a modification of pointer, right? You are not modifying anything in the like actual linked list. But yeah, actually, like you make a valid point. Actually, it is like only one pointer, right? Let's say this is the linked list. You want to insert an element. This is the only connection which you want to make. You are saying ki you are setting this to null also. That is not a modification of pointer, like so. But yeah, actually, ideally you are right. Like in some sense you might claim, but like you should not be answering that. Okay. Cool. Last के next तो new node है. That's the only modification we need, Hemant. You are right. That's the only modification we need. Last का next should be new node. That's it. You are saying कि new node का next should also be null. That is not valid. Okay. Cool. So what is the time complexity to insert an element to the rear of a linked list? Head pointer is given. Again, very simple problem. You want to insert an element in the end of the linked list given the head pointer. Very simple problem. Okay. In the middle also, at the end also, it will take order n, right? But surprisingly, these questions have been asked in all sorts of interviews. Okay, all companies. Even Microsoft, like if they take a coding test, they will ask questions like this. Okay, so if you want to insert an element at the end, head pointer is given, traverse till the end, and insert an element there. So big O of end time, correct, Sarvesh. Okay, big O of end time, very simple problem. Okay, next problem coming is like slightly tricky. What does the following function do for a given linked list with the first node as head? So you're given the head pointer. You're given the head pointer to a linked list. What will this function do? Reverse order, Hemant is saying. Okay, I guess the live stream has been live for like quite a few time now. Like actually, like even I will get tired. Like if I take the entire 30 questions today. So let's do 30 questions today, and we will create another session for the remaining 20 questions. How does it that sound? Okay, we are already at 26, question number 26. Let's do 5 more questions. 26, 27, 28, 29, 30. We will do 30 today. We will create another session for the remaining 20 questions. That session will be like conducted really soon. I will let you know tomorrow or like this weekend. Cool. In the Telegram group, you'll get the invitation. That link to the Telegram channel is pinned in the chat. And there is a new channel by Unacademy Grow. There is a new channel by Unacademy, which is Unacademy Empower. And the link to the Unacademy Empower channel is also in the chat. I will tell you about this channel later, okay? At the end of the video. Cool. So what does it do? It will print the elements in the reverse order. This is correct. So how will it do that? You are given the head pointer. That's okay. This is our head pointer. If head is null, we will return. Right now head is not null. So we'll again call the same function fun1 with head connect. That's okay. We will again call it for the head connect, head connect, head connect, and then we will call it for head connect, which is actually null. So we'll return. And then in the reverse order, we will print the data. So if the data was like this, 1, 2, 3, 4, 5, if the data had been like this, 1, 2, 3, 4, 5, in the reverse order, it will print it like 5, 4, 3, 2, 1. Recursion is a stack. So whatever comes in last goes out first. So it will print all the nodes in reverse order. Cool. Let's move to the next problem. In a circular linked list, insertion of node requires the modification of how many pointers? In a circular linked list, insertion of a node requires modification of how many pointers? 2 pointers. Okay, correct. So this is a circular linked list. Let's say I want to insert a node here. I will have to make corrections in 2 pointers. Firstly, I'll make this connection and then I'll make this connection. So there are 2 pointers which are modified. Very simple problem, okay? Right. Okay, this is very tricky problem. So given pointer to a node X in a singly linked list. So given a singly linked list. Let's say this is your linked list. And given you're given pointer to a node X, let's say you're given pointer to third node. So basically you're given this pointer. So given pointer to a node X in a singly linked list, only one pointer is given. Pointer to the head node is not given. So you're not given pointer to the head node. Only this pointer is given. That's all. Can we delete the node X from the given linked list? Can we delete this node? Can we delete this node? So it is possible if X is not the last node. It is possible if size of the linked list is even. If it is possible if the size of the linked list is odd. And it is possible if X is not the first node. It's a great problem, okay? It's a great problem. Think about it. You're given only one and only one pointer, okay? A single pointer to a random location, like any pointer to any particular node in the linked list. Can you delete this node? You're not given any other pointer. Anyone in the chat? Okay. So actually you can delete it. You can actually delete any node if you're just given the pointer. Think about it. You cannot go to the previous node, I agree. You cannot go to the previous node. But you can always go to the next node. So let's say I have the pointer to this node. I will always have the pointer to next node also. So let's say this is the actual pointer given X. This is the pointer to the next node NXT. What will I do is, since I want to delete this node, I will copy the data of this node to this node. I will just copy the data. I will just copy the data of this node at this node. I will copy 4 here. Because since anyways I had to delete this. Then I will change the next pointer. Then I will change the next pointer of this node to next ka next. This is next ka next. This is next ka next. So then I will change the pointer of the next pointer of this node X to next ka next. And then I will free this memory location. This is actually deletion of any node, right? You can do anything. The only thing which was given was you're given a memory location. You're just given one pointer. You're not given the head pointer. So you cannot go to the previous node. Ideally, how should you delete it? See, since you cannot go to the previous node, you cannot change this link. Since you cannot go to the previous node, you cannot change this link. Ideally, you should have changed this link to delete the node. Ideally, we wanted this, but we did a hack. We actually did a hack. We cannot go to the previous node since we are not given the head pointer. What we will do, we'll go to the next node. We copy the data to this node because this pointer is already established. That's why we have to copy the data. Then I will point the next of this node to next ka next. That's what we will do. Yeah, this is actually cheating, but actually you are deleting, right? Like this is actually, you're not deleting that node actually, but yeah, like, so yeah, but yeah, this is the trick, right? You can delete it, you are not actually deleting that memory location. That's what gate authorities meant back then. But yeah, this is standard trick. If it is asked in interviews, you can tell it at least. Okay, if it is asked in the physical interview, you can tell it. It's a very like brainy trick, right? Only you cannot do this if the element is last node. Okay, if the element which you want to delete is itself the last node, you cannot do this, right? Because you cannot move this pointer and you don't have any other node after it. So it is only possible if the x is not the last node. Otherwise, it is always possible. Think about it, right? So it was a very good problem. Cool. So let's move to the next problem. Given a pointer to node x in a singly linked list, oh sorry, which of the following operations is performed more efficiently by a doubly linked list than a singly linked list? Which of the following operations is efficient when you use a doubly linked list as compared to when you use a singly linked list? Sarvesh, you have a doubt in the previous question, I guess. So you are saying ki can't we check if the next one is null? So delete the node to which pointer is pointing. No. If the node is last node, I hope your doubt is there. If the node is the last node, so next one is null. I agree. But how will you delete this node? See, the previous node is still pointing to this node. You cannot ever change this connection because you are pointing to this node. You cannot change this connection. You cannot go to the previous node. You cannot go here. You can only go to the next. So that's why this node can never be deleted. Okay, let's move to the next problem again. So which of the following operations is performed more efficiently by a doubly linked list than a singly linked list? So Hemant is saying A. Let's see the choices. Let's see option B first. Searching of an unsorted list for a given item. Searching will remain same time because you have to traverse the entire array. Inverting a node after the node with the given location. Inverting a node after the node with given location. So it's like swapping. Okay. So you're given a memory location. You want to swap the elements in the at this node and the next node. So since it is mentioned after, if you had before here, then it would have been better in doubly linked list. But since you're saying after that node, you can always go to the next node even in the singly linked list. So it's like constant time operation in both of them. Traversing a list to process each node, that is like order n in both of them. First is deleting a node whose location is given. So we already know it is not possible to delete a node in a single linked list if it is the last node. Okay. And but in doubly linked list, you can go to the next node or the previous node in constant time. So you can delete any node. You can delete any node in a doubly linked list in constant time. So that's why it is better in doubly linked list as compared to single linked list. Okay. Okay, let's discuss the last problem for today. Question number 30. We will discuss the next 20 problems in the next session. Consider an implementation of unsorted singly linked list. Suppose it has its representation with a head and tail pointer. Given the representation, which of the following operation can be implemented in constant time? So you're given an unsorted singly linked list, and you are given the head and the tail pointer both. You are given the head and the tail pointer both. So this is how your linked list looks like. And you're given the head pointer also, and you're given the tail pointer also. So which of the following operations can be done in constant time? Sarvesh is saying option C. Revant is also saying option C. So let's discuss. It is actually option C. And why? So can you insert it in the front of the linked list? Can you insert in the front of the linked list in constant time? Yes, you can. You are given a new node. You want to insert it in the front. What will you do? You will just point its next pointer to the head, and you will move head to this. You will just make the next pointer to the head, and you will point head to the newly created node. That's it. So this can be done in constant time. Insertion at the end, that can also be done in the constant time. Why? You're given a new node. Again, just point the tails ka next. Just point tail ka next to this newly created node. Just point tail ka next to the newly created node, and then move the tail to the last node. So this can also be done in constant time. Now next is deletion of the front node. Deletion of front node can be done in constant time. How? You just point the head to the next node. You just point the head to the next node and then free this memory location. That's it. That can be done in constant time. Deletion of the last node. Deletion of last node can still not be done in constant time, because it's still, like, anyways you're given the tail. We have already discussed this problem, right? Even if you're given the pointer to the tail, you cannot delete the last node in constant time. You can do it in big of n time. This will take big of n time. Why? Because from tail you cannot go to the previous node. From head you will have to traverse all the way till here. From head you will have to traverse all the way till here. Then only you can delete this node. Then only you can delete this node. So this cannot be done in constant, and this will take order n time. So 1, 2, and 3 are correct. Cool. So do like the video, and let's target like 50 likes. Then only I'll create the remaining 20 questions. Okay, those who are watching the recorded version, don't forget to like the video, and I will make the next part. I will let you know, okay, when I'm creating it. Like, we will have another live session and we will discuss the remaining 20 questions which I have as well. So before going, I would like to know you, let everyone know that Unacademy is launching a new channel which is called Unacademy Empower. Just go check this channel as well. And this new channel is about learning product management. Okay, it's a very important aspect in any IT industry. And if you want to learn product management, you should go to this channel. Here we have 3 PMs already joined. They will be interviewing like different sorts of people like very soon. So do check out this channel as well, and do like and share this video if you like the content, and subscribe to Unacademy Grow as well. Thank you so much, guys. Bye bye.